Good morning, dear students. In the last class, I have explained you about the term conduction. Okay, so in the transfer of heat, there are three modes of transfer of heat: conduction, convection, and radiation. Conduction already I have explained you. Okay, and conduction is applicable, or this process is applicable only in the case of a solid. Okay, not in liquid and gases. So in a conduction, it is applicable only to a solid because here in conduction the heat can be transferred from one body to another without the actual movement of the particles. The particles, they cannot move from one place to another. Now why they cannot move is because they are very much compact. The particles are very close to each other in solid, so they cannot move freely from one place to another. So they can only vibrate within their mean position. Already I have explained this before. So therefore conduction is applicable only in the case of a solid. Okay. And also I have discussed you about the conductor, the non-conductor, okay, or the insulator. I have explained you. Now, and today we will come to the next point, convection. Okay, we will come to the next one. But before we go to the word convection, so one experiment we will discuss it related with conduction, with a conductor. Okay, so water is a bad conductor of heat. Now, how can we show that water is a bad conductor of heat? So for that, we will follow an experiment. So this experiment, to observe that water is a bad conductor of heat, we take a test tube. You know the test tube, it's a long cylindrical glass tube. And fill the test tube with water. Okay, fill the test tube with water. And you take an ice and tie that ice with a copper wire. You know the copper wire, just tie the ice with a copper wire so that the ice could sink at the bottom of the test tube. So in order to make that ice to sink at the bottom of the test tube, the ice is tied with a copper wire. Otherwise, when the ice is not tied with the copper wire, the ice could have been floating on the surface of the water. It remains on the surface of the test tube. Okay, so when it remains on the surface of the test tube, the experiment will not be able to fulfill. Okay, so that means this experiment, we cannot perform the experiment to say. So in order to perform this experiment, you take an ice, tie the ice with a copper wire. Okay, so that the ice could sink at the bottom of the test tube. Now what you do is that now you hold the test tube with a holder. Holder means there is some sort of forceps, okay, where you can hold the test tube. So with the holder, you just hold the test tube and tilt the test tube in an inclined position. Slightly you tilt it. Okay, and what happens is that now you will heat the test tube. The upper portion of the test tube you will heat it. Okay, not the bottom one. The upper portion of the test tube, the upper part of the test tube, which contains water. Okay, so that we heat it. When we heat it, what will happen is that now after some time the test tube gets heated. At the same time, the water on this portion, the upper portion also gets heated up, and the vapor, the steam, you can see here. Okay, the steam rises out. That means the vapor comes out. The water gets heated. So though the water gets heated, okay, but the ice will not melt here. The ice will not melt at the bottom of the test tube, which means that though the water gets heated up on the upper portion of the test tube, the heat is not transferring. That means the heat has not been transferred from the upper portion of the heated water towards the lower portion of the cold water. That means the heat has not been transferred. If the heat could have been transferred, then the ice could have been melted. So, though you supply the heat on the upper portion of the test tube, okay, the water gets heated, okay, and the vapor, the steam starts rising out, the steam starts coming out from the mouth of the test tube, but the ice will not be able to melt. Okay, so this experiment shows that water is a bad conductor of heat. Water is a bad conductor of heat. If the water could have been a good conductor of heat, then the heat could have been transferred Since the upper portion of the water is heated, so the heat could have been transferred from the hotter portion of the water towards the colder portion of the water. So this could be happening. But here, this this process is not occurring, it's not taking place here. Only the upper portion of the water is heating up, but the lower portion of the water still remains cold. So since the water remains cold, the ice will not be able to melt. So this experiment shows that water is a bad conductor of heat. Okay, so this is one of the experiments. Now today let us come to the term convection. Okay, convection. Now convection, it is the process in which the heat is transferred from one body to another, that is from the hotter body towards the colder body, by the actual movement of the particles. Here the movement of particles, here the actual movement of particles takes place. And this convection takes place in a liquid and gases. Convection takes place in liquid and gases. Here there is an actual movement of the particles, okay, between the hotter body and the colder body. So how the convection, how we can describe convection is that, now let us consider a basket. Okay, a teacher has brought a basket of apples. Okay, and he or she will keep it on the table. And the teacher will ask every student to come one by one and take the share. Okay, to take the share and go to the respective places. So the teacher will keep that basket on the table and he or she will call one student, one by one. Each student will be called. And each student will come and take his or her share and go to the respective places. So that is convection. Okay, so how we can say that there is convection is, now consider that basket, okay, which contains a apple, which is filled with the apples, okay, the basket which is filled with apple, and that basket is heated up. Okay, that means that is the main source of heat. Okay, and the student who comes one by one to take their share. Okay, that students are the particles. Okay, or the molecules, I consider. And one student will come and take his share. Again, another student will come, take her share, like that. So one by one, the entire student will get a share in the classroom. So that means, so what happens is that, so here the particles are moving. There is the actual movement of the particles. So this example shows the process of convection. Okay. So therefore, when we come to the definition of convection, so convection is the process in which the heat is transmitted. It is the process in which the heat is transmitted in liquid and gases by the actual movement of the particles. It is the process in which the heat is transferred from between liquid and gases by the actual movement of the particles, which we call it as a convection. Okay, and this convection is applicable only in liquid and gases, because in liquid and gases the particles are free. Okay, they are not compact, they are not very tightly packed, they are not very compact, so the molecules or the particles can move freely. So therefore convection is applicable only in the liquid and gases, not in solid. Now after that, let us come to the convection current. Okay, after convection, let us come to the next point, convection current. Now convection current means the movement of warm air, okay, the movement of warm air away from the hotter body, movement of warm air away from the hotter object along with the flow of the cooler air towards the hotter object is known as the convection current. So that means how we can understand this convection current is, now you light a heater during the winters. You light a heater in a room. So when you light a heater, after some time the entire room becomes warmed. Okay, the air inside the room becomes warm, especially during the winter. Now how it happens is that in one corner of a room, you light a heater, and since the room contains air, okay. Now what happens is that when you light the heater it starts heating up. It becomes heated, and when it starts heated, the air which are near to the heater, they becomes warm. They becomes heated or they becomes warm. And when they becomes warm, they becomes very light, mean to say less dense. The air which are closer to the heater becomes less dense or becomes very light, and the light air they rises up. This is the air becomes very light, okay, so they rises up. So they rises up and they move away from the heater. And that place is now occupied by the colder air. That means the lighter air will move up, they go away from the heater, and the cooler air will again come near to the heater. And similarly the cold air will also get heated up. So this process continues. This process continues till unless and until all the air in a room gets heated up or it gets warm. So this way the entire air inside the room gets heated, it becomes warm. So therefore, when you enter inside a room where you are using a heater, especially during the winters, you observe this, okay, from outside, from a very freezing cold, from a very cold place, okay, when you just enter inside a room, you feel very warm, and you will say that this room is very warm. So why you are feeling warm? Because the air inside the room gets heated up. And how they are heating? Because of the convection. So this way we call it as this process is known as the convection. So when we come to the definition of the convection, so convection is the movement of warm air. The movement of warm air away from the hotter object. Movement of warm air away from the hotter object along with the flow of cooler air near to the hotter object is called the convection current. So this is known as the convection current. Okay. So let us follow the example of the convection current. That is the two experiments we will follow this here. Okay. So convection current in a liquid and other one is the convection current in air. So in a convection current in liquid, you take a round bottom flask. This is a round bottom flask. You fill with water and you take a chemical known as KMnO4, that is potassium permanganate. In order to see, and this potassium permanganate will make the water color. Okay, so you can see the colored water moving up. Okay, so in order to make the water visible, okay, so since the water is the color is liquid, so in order to make the water colorful, we will add one chemical here known as the potassium permanganate, written as KMnO4. So round bottom flask filled with water, you take a potassium permanganate, and other one is a wire glass. Wire glass means they are some sort of wire, some sort of plate like structure is there. This kind of structure, like this kind of structure. Okay, so you just keep it on the tripod stand. This is a stand here on the top of the tripod stand. Okay, stand, you just keep a wire glass on the top of it. You will keep a round bottom flask. Okay, and this is the tripod stand and burner. You supply the heat. Okay, and this round bottom flask is kept erect with the help of the stand here. Okay, so this is the way how the experiment follows. Okay, now what happens that now you put the potassium permanganate inside the water. So when you place a potassium permanganate inside the water, okay, it does not melt. Now as soon as you place the potassium permanganate, then what will happen? You supply the heat. Now this we call it as a burner. You supply the heat here. When you supply the heat, the flask will get heated up. That means at first the bottom of the flask will heat. And when the bottom of the flask will heat first, that heat will be transferred towards the water, and the water will also start heating up. And when the water will start heating up, you will observe that the bubbles of water it starts rising up. Okay, that is the water it starts, the bubbles of water it starts rising from the bottom of the flask upward. Okay, and and as long as the water will start heating, okay, the water becomes warmer and warmer and warmer, and finally what will happen is that this from the middle, from the bottom side, from this side the water it rises up, okay. But at the lateral surface, we call it this one, lateral surface of the flask, okay, or we call it at the side of the flask. The side of the flask, the water is not that much heated as it is heated at the center, because you are heating you are supplying the heat at the center, that is at the bottom of the flask, okay, not at the sideways. So this part of the flask was heated, and the water will receive the heat, and when the water will receive the heat, they becomes warm, and when they become warm, they rises up, okay, they rises up. When they rises up, okay, that means now this portion, when the water gets heated up, they becomes warm and they become less dense also. They becomes very light. Less dense means they becomes light. When they become light, they rises up. And this warm water, the place of this warm water will now occupied by the cold water. Now the cold water will come. Cold water will also get heated up. Again, this will rise. Again, the remaining cold water again comes down. Again, it rises. So that this process continues unless and until the entire water in a round bottom flask be heated up. So this experiment shows the convection current in a liquid. Okay, so this is a very simple experiment. Okay, so after some time the entire water in a round bottom flask will get heated up. Though you have supplied the heat, especially at the middle of the glass container. That means at the middle of the flask. But the entire water gets heated. The whole water in a flask gets heated up. So how they get heated up? That is based on the convection current in the liquid. So the next one is the convection current in air. Now what you do is that now you take a trough. This is the trough. You take a lighted candle, okay, and you take a lighted candle and you take a chimney. This is the chimney, okay, chimney of this one. Lamp you can take it, okay, kerosene lamp. You know the kerosene lamp, the glass chimney. You just take it here. You take a lighted candle, cover the lighted candle with the chimney. Okay, then after that, what you do? You pour the water here. You pour the water in a trough. Okay, and when you pour the water, what will happen is that, and after that, you will take a cardboard, a T-shaped cardboard. So what are the things required is, one is a chimney, one is a trough which is filled with the water, other one is a lighted candle, okay, and cardboard, a T-shaped cardboard. These are the things you take. Now you light a candle, and lighted candle is now covered with a chimney. When it is covered with a chimney, it blows out by itself, because the candle cannot keeps on burning, okay, because, and this side we have covered it. Okay, the top portion we have covered it, and as soon as you cover it, after some time the candle it blows away because there is no oxygen. Now fill the trough with water here, then again you light the candle. Again you light the candle, and this side you keep open. Okay, this side you keep open, so the air will pass through it. Okay, and now the candle keep on burning. Candle now keep on burning. Now after that, what you do is that, now you will take that this side. Now when the candle starts burning and you just keep your hand on the top of the chimney, you will find a warm air on your palm. That means the warm air coming out from the burning candle towards your hand. You will feel that. So how it happens is that the warm air is becoming less dense, so they are rising up from the chimney, and the cold air is entering inside. Warm air will move upward, okay, and the cold air will move down. Now in the burning candle, now you bring an incense stick. You know the incense stick is the doot, okay, and this side will keep a cardboard, okay, T-shaped cardboard, okay, and what you do is that now you keep an incense stick on one side here. What will happen? That smoke will move inside. That smoke will move inside. So when the smoke, this arrow sign shows that the smoke is moving inside. The smoke which are coming from the incense stick, it moves inside, okay, and on the other side it moves out. Okay, so why they are moving inside is that means that smoke will go downwards. Okay, and when they go downwards, they become heated up because of the candle, because of the heat which has been produced from the candle. They get heated up. When they get heated up, they become less dense. They become light, and that layer and that smoke again it rises up from the comes out from the other part of the chimney. Okay, so this way what happens here is that the convection current is also developed in air. Not only in liquid, the convection current also develops in air. Okay, so these are the experiment which can prove the convection current in liquid as well as in convection current in air. In the next class, we will come to the application of convections. Thank you.